where Earth is only one of numerous planets in the universe, and wise life is who knows where. Very much like how, on Earth, are we expected to know? Before you excuse this as a ludicrous inquiry, I strongly suggest you watch this video. It could alter your viewpoint. Over the course of the last years, NASA has vigorously invested in exploring extraterrestrial life. They've sent a great many satellites into space, built scientific labs on the moon, and drafted thousands of groundbreaking reports about what it might be like to find alien life. Music. So, watch this video if you are ready for some staggering information about extraterrestrials. Number 5 will stun you. Make sure to like, share, comment, and subscribe to our feed for additional videos like this. TESS has been in space for only a couple of days, yet researchers have already identified where life could be possible. Over the last few years, NASA's Kepler telescope has discovered thousands of planets that are pretty much Earth-sized. By using artificial intelligence and machine learning to analyze their brightness, project scientists were able to determine which ones had atmospheres. The telescope identified 10 new planets that orbit within the habitable zone of their stars. That is the range of distances where liquid water could exist on the surface. Music. The TESS telescope, the Transiting Exoplanet Survey satellite, is the replacement for NASA's Kepler Space Telescope and is designed to search for planets outside our solar system. TESS looks for exoplanets in the solar neighborhood, especially those orbiting bright nearby stars that are already known to have transiting planets. These can then be followed up with ground-based and space-based telescopes. The vital objective of the TESS mission is to detect small planets with bright host stars in the solar neighborhood so that detailed characterization of the planets and their atmospheres can be performed. The telescope, which is the result of decades of work and billions of dollars, scans the entire sky in both the northern and southern hemispheres, searching for small planets that orbit stars other than our Sun. It was launched on April 20th and began operating immediately. Among the 10,000 candidates it has identified so far are planets that are hotter than Mercury. Some of these sit in the Goldilocks zone, where liquid water can exist on their surfaces. Inside that zone, a planet's atmosphere and temperature must not be too extreme. One of the planets found by TESS is HD 209 to 458b. This planet is 169 light-years away and orbits a star that is smaller and cooler than our Sun. The planet is believed to have an atmosphere that contains water vapor and carbon dioxide. It is thought to be a super-Earth. What do researchers mean by the habitable zone? There are several factors considered when determining if a planet's atmosphere is habitable. Water vapor content. The most essential requirement is that a planet has water vapor in its atmosphere. If there is a liquid water-containing component, it is believed that it would either be liquid or solid water. Furthermore, the temperature on the planet significantly affects the water. At the lower end of the habitable zone, below 100 Kelvin, or minus 279 degrees Fahrenheit, water vapor condenses into liquid drops, as on Earth. At temperatures much beyond this range, it would form ice. Gas temperature. Another factor to consider is the temperature of the atmospheric gas composition. The upper limit for water vapor is around 100 Kelvin, or minus 279 degrees Fahrenheit. Air warmer than 35 Kelvin, about minus 396 degrees Fahrenheit, contains more gases that are likely to absorb heat and not release it as easily as oxygen and nitrogen do on Earth. Surface composition. At the upper end of the habitable zone, water vapor condenses into liquid drops. It would form ice at temperatures above 100 Kelvin, 60 degrees Fahrenheit. However, at extremely high temperatures, the sulfur content of the planet's atmosphere becomes significant. For super-Earths and planets with a ring-like world but no atmosphere, it must also be tempered enough to support liquid water. TESS candidates must also be rocky planets. Too much gas, and they would be Neptune-like. Too little, and they'll be Jupiter-like. If rings surround a planet, astronomers deduce that there is very little in the atmosphere. Rings don't tend to form around gaseous worlds. All these factors have been considered by planetary scientists, and while it might still be too early to determine which specific planet TESS will find a habitable atmosphere on, the fact that this is even possible demonstrates the power of all-sky surveys like TESS. This video represents a summary below that illustrates the habitable planets and their characteristics. Kepler 7b. This planet orbits around its star in a relatively close orbit, making it less than the distance where liquid water could be stable. However, the planet isn't too close to its star, close enough that water could exist on its surface. Also, Kepler 7b is much closer to its star than Neptune is to the Sun. Neptune is about 30 times farther from the Sun than Kepler 7b is from its star. It would be a phenomenal candidate for detailed analysis with a spectroscope and other tools, which would tell us more about the planet's atmosphere and structure. Kepler 7b is the smallest exoplanet ever discovered orbiting a star at its disclosure. It is marked as the first extrasolar planet to have clouds mapped, revealing a bright spot on the planet. It also showed moon-like phases when orbiting its star, which scientists could only hypothesize about before this discovery. Kepler 186f. Kepler 186f is considered an Earth-like planet because it is the right distance from its star to have liquid water on its surface. The exoplanet has no oceans. Additionally, it is in a habitable zone and contains the light elements hydrogen and helium, but not the heavier elements like oxygen and carbon. Because no liquid water was detected on Kepler 186f, researchers continue to debate its habitability. On the surface, this implies that water on a planetary scale could either be frozen or concentrated in specific areas such as underground aquifers or profound lakes. This concept is crucial when studying exoplanets, particularly those located within their star's habitable zones, where liquid water, a key ingredient for life as we know it, could potentially exist. Below is an exploration of some of the most promising exoplanets identified by NASA's Kepler mission and other observational tools, each with unique characteristics that make them intriguing candidates for further study. 1. Kepler 186f. Kepler 186f is classified as a super-Earth, with a mass approximately 3.5 times that of Earth. This exoplanet orbits its star at roughly one-third the distance Earth orbits the Sun, placing it within its star's habitable zone where liquid water could remain stable. Despite its proximity to the star, its location in the habitable zone makes it an excellent candidate for future spectroscopic analysis. Advanced instruments could help determine the composition of its atmosphere, shedding light on potential habitability. 2. Kepler 438b. Kepler 438b is another fascinating exoplanet, known to be tidally locked with its host star. This means that the same side of the planet always faces the star. Kepler 438b resides just outside the range where liquid water could be stable, yet it remains a strong candidate for habitability due to its magnetic field, which might protect it from harmful stellar radiation. If this planet has an atmosphere, it could contain vital elements such as carbon dioxide, nitrogen, water vapor, and methane, ingredients necessary for life. With a mass 2.3 times that of Earth, its gravity would be roughly 3 times stronger than Earth's, creating surface conditions that could still support life. 3. Kepler 62f. Kepler 62f shares several similarities with Kepler 186f. It is situated in its star's habitable zone and has a good chance of harboring liquid water. However, it is colder than Kepler 186f due to its star's properties. Despite this, its relatively small mass, 1.6 Earth masses, suggests it might have low surface gravity, which could allow for shallow oceans or lakes if geological activity facilitated their formation. If Kepler 62f has an atmosphere, it might contain carbon dioxide and other volatiles, which could stabilize surface temperatures. 4. Kepler 296f. This super-Earth is located in the habitable zone of its star, albeit near the outer edge. It is believed to have characteristics similar to the ice giants Uranus and Neptune but on a smaller scale. Its size indicates the potential for a dense atmosphere, which could include elements like water vapor, methane, and carbon dioxide. However, frequent stellar flares from its host star could impact its habitability. 5. Kepler 22b. Kepler's 22b orbits firmly within the habitable zone of its star, providing conditions that might allow for liquid water. Although its mass and size are similar to Jupiter, making surface gravity high, it remains a key target for researchers due to its location in the habitable zone. At 600 light-years away, its distance presents challenges but also opportunities for studying atmospheric composition. 6. Kepler-36b. Discovered in 2009, Kepler-36b is a smaller planet with Earth-like characteristics. Its orbit within the habitable zone suggests potential for liquid water, though its eccentric orbit might eventually push it out of the habitable zone. The planet completes an orbit in just 14 days, much shorter than Earth's year. 7. Kepler-442b. With a mass and size similar to Earth, Kepler-442b is another exciting prospect for further study. It resides in its star's habitable zone, and its atmosphere might contain life-supporting compounds like methane and carbon dioxide. Its similarities to Earth make it a top candidate for potential habitability. 8. HD 40307g. Located just 42 light-years away, HD 40307g is a promising super-Earth in its star's habitable zone. Its mass and size make it an excellent candidate for studying atmospheric conditions and the presence of water. Its proximity to Earth makes it particularly intriguing for future exploration. 9. Kepler-69b. Though less Earth-like than some other planets, Kepler-69b still offers potential due to its rocky nature and position in the habitable zone. If it has an atmosphere, it may include methane and carbon dioxide, crucial elements for life. 10. K225b. K225b is a small, rocky planet located within its star's habitable zone. With a mass and size similar to Earth, it offers strong potential for hosting water. It completes an orbit in just 3.5 days, indicating close proximity to its host star. Conclusion: NASA's Kepler Space Telescope and other missions continue to identify promising exoplanets that expand our understanding of potential habitable worlds. While some planets are better candidates for life than others, each discovery increases the likelihood of finding extraterrestrial life within the next few centuries. The ongoing exploration of these distant worlds inspires hope and wonder about our place in the universe. What do you think? Will we find alien life in the near future? Let us know in the comments, and don't forget to like, share, and subscribe for more content like this. The least demanding way for us as humans to comprehend something is often through visual perception. When we can understand a situation with the unaided eye, it seems clearer. The effects and causes of a particular process become more tangible. However, what happens when we encounter situations that are entirely invisible to the natural eye? The mysteries surrounding the boundless vastness of our universe stem primarily from the fact that we simply cannot observe certain areas of the cosmos due to the various spatial conditions that limit us. Today, we invite you on a journey into the unknown. Our focus is on what lies beyond the visible universe. Leaving Earth, the only home we've ever known, we venture to the farthest reaches of existence. If you would like to join us on this journey, please support us with a thumbs up, subscribe to Essentially Space, and look forward to the exciting videos we will share in the future. The origin of the universe. To begin understanding what lies outside the visible universe, it is essential first to examine how the universe itself came to exist. You have likely heard of the renowned theory explaining the origin of all things, the Big Bang Theory. This cosmological proposition addresses the emergence of space-time and matter. According to scientists, the Big Bang, widely considered the birth of our universe, occurred approximately 13.8 billion years ago. Contrary to popular assumptions, most Big Bang theories do not focus on the explosion itself but rather on the earliest state of the universe following this monumental event. The term Big Bang might evoke images of a colossal explosion that sent the fragments of our universe flying like projectiles into the infinite expanse of space. However, the Big Bang actually describes the emergence of matter and reality from a prior singularity. In astronomy, a singularity refers to a spatial state where gravity is so intense that space-time curvature becomes nearly infinite. By studying the spatial expansion of our universe in reverse, researchers attempt to trace its evolution back to its initial moments. Despite their efforts, scientists remain largely in the dark regarding the precise origin or the conditions of the earliest universe. As of now, no universally accepted theory can irrefutably explain the exact beginnings of our cosmos. The observable universe. As mentioned earlier, it is not possible for humanity to observe every distant corner of the universe. On the other hand, there are areas that we can study using advanced technical equipment. This observable portion of the cosmos is commonly referred to as the visible universe. In some representations, the visible universe is depicted as a spherical structure. This geometric depiction stems from the fact that Earth is placed at the center as a kind of observational vantage point. The circularly described surroundings merely reflect the radius observable from Earth and do not represent the true shape of the universe. This conceptual framework can be applied to any celestial body in the universe. The area we can observe from Earth is determined by the so-called event horizon. The event horizon defines the distance at which light from an object in the universe can reach us. In current scientific models, the event horizon is estimated to extend approximately 16.2 billion light-years. Due to the continuous expansion of the universe, certain celestial bodies will become visible in the future, while others will move beyond our observational reach. At some point, objects located beyond the so-called Hubble radius will never be observable from Earth because the universe's expansion will cause them to recede faster than the speed of light. Additionally, objects we can see today may eventually disappear from view as the expansion continues. Does the universe have an edge? When discussing the universe, space is often described as infinitely vast. Scientists agree that the universe is constantly expanding at an incredible rate. This raises the intriguing question: into what is the universe expanding, and could this region be finite? Is it possible, then, that the universe has some sort of edge? This question has sparked much debate among researchers. Simply put, we might wonder whether there is a boundary point in the universe beyond which one could glimpse an unknown domain. If we were to liken the universe to a self-contained structure, is there a window in its walls through which we can look out? Most experts agree that this is unlikely. Their reasoning stems from the cosmological principle, which posits that the distribution of matter in the universe appears roughly the same when viewed from any location. In general, researchers believe that the universe is isotropic, meaning that it has no preferred direction. As a result, there is likely no clearly defined edge to the universe. To illustrate this concept, scientists often compare the spatial nature of the universe to the surface of a balloon. If a small bug were to crawl on this balloon, it could move in any direction without encountering an edge. What lies beyond the observable universe? Having briefly explored the foundational concepts of the universe, let us return to the original question: what lies beyond the observable universe? Addressing this mystery requires delving into the realm of theoretical science. Many experts believe that the unobservable universe is structured similarly to the visible one. Given the hypothesis that the universe has no defined edge and is essentially infinite, this theory appears plausible. The boundless nature of space suggests that beyond the visible universe lie countless other stars, planets, and celestial bodies, perhaps even more than we can currently fathom. According to this line of thinking, the vastness of infinity implies the existence of doppelgangers, individuals nearly identical to each of us, differing only in minute ways. While this notion may seem unfathomable, it reflects the sheer scale of infinity, a concept that challenges our comprehension. Other theories speculate about massive structures beyond the visible universe that exert a gravitational pull on nearby objects. These structures, detected in 2008 through observations of galaxy clusters moving in unison at incredible speeds, remain enigmatic. They could be massive collections of matter or distortions in spacetime. Another hypothesis posits that our universe is just one of countless others in a multiverse. This multiverse theory envisions a collection of infinite individual universes existing side by side, much like tiny bubbles in a vast foam. Conclusion: for now, the question of what lies beyond the observable universe remains an open mystery. How long will it take for humanity to unravel this cosmic puzzle? We hope our journey to the edges of the universe was both engaging and enlightening. Which theory do you find most plausible? Do you have your own ideas about the hidden realms of the universe? Share your thoughts in the comments, and we'll see you next time.